Good morning and thanks everybody to be here this morning. The title of my speech is Some Aspects of Component-to-Component Interaction in Data Visualization. The context of the speech is divided in 4 sections. Firstly, a brief introduction about the context of the thesis. Secondly, key aspects about the component-to-component interaction analysis, a new method to analyze interactivity on data visualization applications included on my master thesis research. The speech will continue with details about the experiment that I led as part of my master thesis too. I'll finish the presentation with a final section with the results of the experiment, the discussions and conclusions of the research. At the end, we'll start a round of questions about the topic. Let's start with the context of the thesis. Data visualization is an emerging and interdisciplinary field. Each day, it becomes more relevant. Ben Snyderman defines data visualization as the use of computer-supported, interactive, visual representations of data to amplify cognition. It's not casual that this definition includes interactivity as a must. Over the last decades, the number of scientific publications about data visualization has grown. However, interactivity on data visualization is an open issue. On the left column, you could find appreciations from recent publications about the topic supporting this idea. For instance, Meyer on his paper, From Visualization to Visually Enabled Reasoning, said that the process of stimulating and enabling human reasoning with the aid of interactive visualization tools is still a highly unexplored field. The problem statement of the thesis is explore the impact on user understanding when the component-to-component interaction of a data visualization changes. Every data visualization layout can be analyzed being decomposed in components. On interactive data visualizations, users can interact with these components. However, when the state of a component changes, it could affect another components too. This is called component-to-component interaction. I didn't find any publication that studied this kind of interactivity. The paradox is that the most related publication that I found about the topic is about static visual representations. I'm referring to the Language of Graphics by Engelhardt, 2003. This publication studies the semiotic meaning of components in static graphics, creating a network among components. This thesis will do 2 contributions to the resolution of the problem. The first contribution will be a simple visual framework to study component-to-component interaction network, and the second contribution will be a specific experiment about the user's impact of a specific component-to-component interaction. This was the state of the art up to here. Now I'll start with a more detailed specification of the component-to-component interaction analysis. I create a method to visualize analysis of component-to-component interaction. The main goal is to represent the system of interaction among components in a network. From this system emerges the human data visualization interactivity. To extract the component-to-component interaction, it's needed to follow the 5 steps presented on the slide. An example of this process is the very brief component-to-component interaction network analysis of Gapminder in the following slides. Gapminder is a data visualization used to increase the knowledge about social and economic development at global levels about countries. Hans Rosling, the main author, popularizes this tool on his viral TED Talk participations. Considering that the component-to-component interaction network is formed by nodes that represent components, connections, that represents interactions, and considering too that each interaction is produced by an action and produces an effect, we will use this schema to represent the component-to-component interaction. This is the component-to-component interaction network of Gantminder. The figure shows how the interactive layout follows a highly centralized mode. Most of the visual space belongs to the scatter, and every peripheral component is designed to help the protagonist, the scatter, to communicate the message to the audience. Although it is needed to explore more systematically the concept of component-to-component interaction network analysis, the visual method is able to provide a representational common language to communicate changes to the component-to-component interaction network. And more important, these changes can be tested empirically. The experiment of the thesis is an example. The experiment of the thesis is an example of how can be measured the user impact of a specific component-to-component interaction. This is a real interactive data visualization application that I developed with the unique purpose to perform the experiment. Two versions were developed. The graphic components are the same on both versions, and the actions that the user can apply to the layout are the same on both versions too, but each version has different component-to-component interaction network. This is the component-to-component interaction network for the control group, and this is the component-to-component interaction network of the target group. It is the same that in the control group, but adding a connection between the news grid and the temporal range and the time range selector. When an article is selected by click from the news grid, the time range selector is set around the published date of the article. Component-to-component interaction becomes now cyclical. What are the effects to increase the connectivity and the complexity among component connections? The effects are going to be measured in function of two dimensions. The first dimension is the effectiveness of the application. That's the capability of the application to provide to the users the correct answers from the source data. It will be represented by the number of correct answered questions. The second dimension is the efficiency of the application. That's the capability to answer to the questions in less time. On the experiment, the period of time is limited, so it will be represented by the number of total answered questions. These are the hypotheses contrast. The first hypothesis states that effectiveness on the target group, adding the target feature, increases the effectiveness respect to the control group. The second hypothesis states that the efficiency on the target group increases respect to the control group. In other words, adding the connection to the component-to-component interaction network improves the application performance. 20 participants performed the experiment. They were divided in two groups, and each group was assigned to an application version. Remember that versions only differ in the component-to-component interaction network. Both groups answered the same question, 8 questions on a limited time of 13 minutes. The statistical contrast of the results were obtained with the t-test method. The English level, the level of studies, the sex, and the country classifies each participant. The sample was divided in two balanced groups randomly, but in a way that both groups were comparable. About the location, each time that a participant performed the experiment, some conditions were created. There are more people in the room, there are noise that can disturb to the performance, and the table of the user experiment was empty except the computer. I start the last part of the presentation. the discussion of the project. The effectiveness of the application was operationalized as the number of core tasks. The target group obtained an average effectiveness score of 3.6 over 8. The control group obtained an average effectiveness score of 2.5 over 8. After conducting a statistical hypothesis test of type t-test, it was found that the target group obtained a better score than the control group, with a p-value of 0.077, supporting the original hypothesis that the effectiveness increased for the target group. The efficiency of the application was operationalized as the number of total answered questions. The target group obtained an average efficiency score of 5.6 over 8. The control group obtained an average effectiveness score of 6.3 over 8. After conducting a statistical hypothesis test of type t-test, it was found that the target group obtained a lower score than the control group, with a p-value of 0.19. Although this p-value is clearly not significant, it is relevant that the efficiency of the target group decreases in relation to the control group. The change applied to the component-to-component interaction network decreased the efficiency instead of improved it. There were another aspects that were analysis on the experiment. This slide clarifies them. For instance, more people suggested improvements on the target group than in the control group, or both groups rated the application practically with the same average score. But the most important aspect on the slide is the load system. Every action that the user did while was performing the experiment was recorded on a log system. I used this information to control that every user on the target group used the target feature. After conducting the experiment, it was observed an improvement of the effectiveness of the application, as we talked before. Although the p-test value is not under the 0.05, it is a good result and indicates that linking these two components was a good approach to help users to be more accurate on their answers. This effect could be produced because on this way the application helps to the users to focus on the task. In conclusion, on the target group. Users were able to be more accurate on their answers, and adding the target component-to-component interaction connection is interesting to an expert audience. But the efficiency of the application didn't increase. In fact, it decreases. Although the statistical p-test score was not significant, this effect, the result is significant. This effect could be produced because adding the connection to the component-to-component interaction network increases the complexity of the application. In conclusion, on the target group, more time could be needed to understanding how the application works and how to take advantage to the added new feature. And it is not convenient to add this connection for a mainstream audience. At this point, there are several issues to continue the research. On this slide are included 4 of them. Maybe the most important work to continue is exploring a more systematically concept of the concept of component-to-component interaction network analysis. And now, if the professor agrees, we can begin with a round of questions.